Okay, as you can see, the General Electric SuperBase model 3-5875A is back up and running. All of the electrolytic capacitor has been changed. This is the one that had the leaky capacitor on the bottom circuit board and ate away traces on both sides of the board, so that's all been repaired. All the other electrolytic capacitors replaced on both those boards. Power supply down on the module board here, and on the turned around here on the microphone compression module board down here, they've all been changed. And like I had said, great radios, just horrible to have to get the capacitors, because to get to every capacitor except for the two on the power supply board, that one and that one, every other capacitor to get to it, you have to remove circuit boards, and it's a bit of a chore. But they've all been replaced. It's all back together. The alignment's been done. This has now had two modifications done to it. The meter lights were replaced to LEDs, and they're now also connected to the dimmer circuit. The way these were set up originally, the dimmer circuit only affected the channel display and the clock. So now the meter lights are also attached to the dimmer control here. So you can see as the display gets dim, the meter lights go dim accordingly. So, and you can see the LEDs that I use, it's a nice even display. I don't use those ones that leave a little hot spot ring right in the middle. I like to use the ones that give have a really wide beam projection pattern. But the only other modification that was done, like I say, so we got the meter lights and the clarifier's been unlocked. So other than that, this is original, no other modifications. I'd taken the faceplate off of this. The customer asked if I'd clean this up as best as possible. So faceplate was taken off, the meter lens taken out. I'd showed that in a previous video. How you get the faceplates off of these, how this switch assembly retracts into the radio, and then how you get this lens out. So that's been removed. All of the dust bunnies, usually you can see in these radios a collection of dust over in the corners. It builds up in the corners. So lens has been taken off. That's all been cleaned out, and then the lens has been polished. So that's been buffed on a Baldor buffer and plastic polishing compound. So that's mirror finish now. So as you can hear, it was hooked. It's hooked up to the antenna, and that's on antenna A. So on antenna B is connected to the spectrum analyzer. So let's go to center channel here. So it's an AM. There's the microphone that's connected to this radio. And that's hooked up, like say, antenna B. That goes out this large coax cable here, goes to my normal setup. Grab the flashlight. 230 dB high power attenuators in series. So there's 60 dB of attenuation, and it comes out of the second attenuator, goes straight into the spectrum analyzer. So the spectrum analyzer is the dummy load, and amplitude reference offset has been set to the 60 dB. I currently have it set with a start frequency of 20 megahertz, stop frequency of 60 megahertz. So you can see the carrier, and most radios, your normal largest spur is going to be at 54 megahertz for spurious emissions. So there's the carrier. Audio check 1 2 1 2. That's under modulation. And let's widen it out just in case you might be thinking this has a very good 54 megahertz trap circuit. Maybe it's got spurs out. So let's go the whole way out to, let's say, 300 megahertz. So now the left side of the screen's 20 megahertz, right side of the screen's 300 megahertz. Audio check 1 2 1 2. Audio check 1 2. Okay, microphone. Cord's getting tied up here. Okay. Audio check 1 2 1 2. So basically no readable spurious emissions on this. Extremely clean talking radio. Go back over to A. And we'll switch over to a dummy load, and we are in AM mode. So the dead key is actually turned down on this radio right now. So you can see it's at about 3 watts, and it's in peak reading. Audio, audio, audio check. So it's doing maybe 13, 14 watts on AM. And switch to sideband. Audio, audio, 1, 2, audio check, 1, 2. So right around 15 to 16 watts on sideband. Now, like I say, it's flip back over, leave it on sideband. We'll flip back over to the spectrum analyzer, and to see how clean this is, we'll put the center frequency 27.205, which is channel 20 that we're on, megahertz, and we'll make the span 10 kilohertz. So here's AM. Audio check, 1, 2, audio check, 1, 2, 3, 4, and lower sideband, audio check, 1, 2, upper sideband. So, good clean talking radio, ready to go back into service for another 30 or so years. Like I say, this one's in really, really nice shape. Fairly low serial number. It's in the. It's not like the one I'd worked on previously. That was I think, what, serial number like 62 or something like that. Easy way to tell this is a later radio. Like I say, that early radio, I'd never even seen one until I took that one apart to refurbish that one. That it was missing. If anybody has watched that video, this plate, if you remember when I had the boards out, I showed this RF shield plate they have in here that covers the entire area in between the 2 circuit boards. That really early model radio did not have that. It only had a small shield board in this area here that was soldered directly to the underside of this board. So that was one obvious revision from the original, first at least 62 radios that came out. I would have to assume maybe the first 100 or so. That was one revision that General Electric had come up with, was to add this shielding plate in between the circuit boards for RF shielding. And I'm thinking they probably did that to keep just that, spurious emissions down. I don't think I put that one on the spectrum analyzer at the time when I did that video, so I don't think that's videoed, but I'd have to assume they probably did that maybe because when you're transmitting, a lot of people think these shield plates they put in radios are to keep emissions getting out of the radio. They think, oh, it's FCC regs to keep, the emissions coming out of the cabinet low. It really has nothing to do with that. I mean, that may be a side benefit, but the shielding's mainly to keep signals from mixing inside the radio. So when you're transmitting, your final section in this radio is back here in the back on the bottom circuit board. So that circuit board's mounted upside down. Well, you have these boards share a lot from top to bottom. Some of the crystals are on the other side, some of the stuff's on this side. You've got some of your frequency adjustments up here, some are on the bottom side. When you're setting your transmit power, some of that adjustment is done up here. Like, here's your carrier suppression controls, here's some of your sideband controls. So a lot of these circuits from top and bottom boards are shared between receive and transmit. So when you're transmitting, the last thing you want is all that signal that's on the frequency you want to be on, but if it gets back into the mixing circuit, it can come up with oddball spurious emissions that aren't wanted. So, like I say, that's the main reason they do shields like that, and I get the feeling it was probably they had a little bit high emissions, and that's probably why they enlarged this plate to cover the entire chassis, or the entire board area between the 2 circuit boards. Other than that, the few other things I noted on that radio was there were a few factory-done modifications on some of the circuit traces, but otherwise they're basically the same, still the same circuit. The circuit diagram you see in the SAM's 234 for the for that model GE SuperBase was basically the same. Like I said, they just made a few improvements, and by the time they got to 6,000, this one, like I said, that's a fairly early serial number. Everything had been, I guess, they'd ironed out any of the kinks in the early model radio. But personally, I think that radio worked just fine. I didn't see any problems with it. But you know, engineers can't be satisfied. And like I said, that's why these are real popular radios. They're really, really good, clean sounding, you know, receiving and transmitting radios. So.
That $50 radio sounds great here. Well, all right.
And as you can see,
I got a $35 wash press. No, it's a president wash. It just don't look too bad.
clarifier centered. Oh, and one thing when I, of course, had the faceplate off, I had all the knobs off, and of course I cleaned those. One thing I noticed was, I think somebody had the wrong knob on here. If I'm not mistaken, this outer clarifier knob had one of these knobs with a line on it. It's not supposed to have the line, because like I say, this one kind of spins independently. If you turn your clarifier to full lock, you can keep, if you notice, it just keeps turning. And same thing the other direction, because it's just a clutch, a friction clutch style. So you can see the back pointer, which is the actual clarifier. That's the one that's actually attached to the potentiometer in there. This outer one's just a friction. So these easily get out of alignment, so there's no use trying to keep a little, you know, arrow on there lined up with your upper arrow there. So like I'd said, if this ever gets out of whack, you know, it's like this. There's a perfect example. It's a little bit out of kilter. The main pointer's dead center there, but you can see it's off. So you can set this if you want flat. Like I say, you just hold the rear, turn the outer knob, and you can see that holds that. Or if you wanted, you could line it so it's straight up and down like I had it there before. So, like I say, it's independent of that. It's just friction drive. So that's, like I say, that's the only thing these can get out of, you know, get out of whack, this outer knob. But that's why it's not supposed to have a line on it. It's not meant to be, you know, that's why the pointer is on the rear part of the clarifier control. So I guess that'll do it for this one. Actually, I think once I get the covers put back on it, I'll just tack on a little extension to this video to show what the radio looks like completely put back together. Because like I say, this one's in really, really nice condition. See the faceplate, the aluminum, and all the silk screen is mint. The only real thing it has is this little scratch. I don't know if you see it right here. There's one little scratch in this top piece right here. Other than that, the faceplate bezel's in excellent condition. So like I said, I guess I'll get the cover back on it and I'll just tack on a little extension so you can see what it looks like fully back together. Okay, now here's the radio with the cover back installed. It's been waxed and buffed, so actually has a little bit of shine to it again instead of the dull finish they attain after 30 years or so. So it looks nice and clean now. It's in excellent shape. And let me get the power cord pulled here and get it flipped around. Back's in really nice condition too. Yeah, little tiny spots of discoloration there, but otherwise the rear is in excellent condition as well. So, and one thing to remember, if you ever get one of these radios, if you don't use the proper power cord, this radio will not work. Notice there's no AC-DC switch on the back of this radio. Okay, most of your base stations radios that operate off, you know, either 13.8, 12, 13.8 volts, or 120 volts have a separate AC-DC power switch. A lot of your Cybernet chassis don't have it. This is one of them. I don't even know if the camera can focus inside the hole or not. But if you look in the top, you see with the flashlight, just barely see there's a little black thing hanging down. You see the two pins, but in the back at the top there's a little square hanging down in there. That, there, so you can see it. If I can get in here with a screwdriver, See, it actually pushes up in. That actually is the power switch. There's a transfer switch to switch from external power supply to internal power supply. So if you use the majority of power cords on the market, in fact, let me reach down and get one of those. This is a very popular power cord right here. You know, I stock these, usually have like 30 or 40 of these things in stock. This plug is not thick enough, okay? And for starters, it has this little divot here. If you put it in that way, it definitely won't fit. But if you install this cord in this socket, there's too much gap in here. See that? And it won't depress that switch. So if you ever get one of these radios, you plug it in your power cord, and the radio just will not come on. You take the covers off, all the fuses on the inside are fine. Check that first. Now you can get this cord to work with this radio. It's real simple. Take a piece of paper, fold it up like maybe 8, 10, layers thick. Just a little square of it. Hold it on top of the plug here when you plug it in. The idea is you want to fill in that gap so it depresses that switch. But just, put a little paper shim in there basically so that the switch is switched over to AC. Because like I say, with this plug installed right now, it's still operating. It's trying to draw power off of the DC socket. So that's just a little tip. If you don't have or can't get the proper power cord, if you're using one like this, like I say, these are very popular. You can still get these things. The larger ones, I have those too, but they're harder to find the proper ones to fit in that hole. So that's just a little trick. Little scrap of paper will get you get that up and running. So I guess that'll conclude it for this radio.